I will be discussing chapter 11.5, problem number 97. Find the distance between the point 0, 0, 0 and the plane 2x plus 3y plus z equals 12. Over here I've drawn a diagram of our plane and our point Q, which is 0, 0, 0. So what we need to do is find a point P within the plane, and then we can easily find a vector between P and Q. We know our normal vector. We can get that from the equation for the plane. And then we project PQ onto N to get this distance here. And since this will be parallel with the distance between Q and the plane, we know that the size of this vector will equal the size of this distance here. So we get the distance equals the magnitude of the projection of PQ onto N, which can be rewritten as the magnitude of the vector PQ dot the vector N over the magnitude of the vector N squared times the vector N. And we know that the magnitude of a constant times a vector is equivalent to the absolute value of that constant times the magnitude of that vector. So that allows us to rewrite this as the absolute value of the vector PQ dot the vector N over the magnitude of the vector N squared, which we don't have to do the absolute value of because we know it'll always be positive, times the magnitude of the vector N. Allows us to cancel out 1, which gives us our final distance formula, which will be the absolute value of the vector PQ dot the vector N all over the magnitude of the normal vector. So the things that we'll need to do. First, we know that our point Q is 0, 0, 0, and our plane is 2x plus 3y plus z minus 12 equals 0. So first we'll find the vector that is normal to the plane, this part here, which we can get from the equation for the plane, 2, 3, 1. So the normal vector will be 2, 3, 1. Find a point in the plane. To do this, we can easily replace the y and the z value with 0. When we do that, we come up with x equals 6. So a point on our plane, 6, 0, 0. And then we find the vector from P to Q using our points P and Q, and we'll come up with the vector negative 6, 0, 0. Next, we'll find the magnitude of the vector N, which is the square root of 2 squared plus 3 squared plus 1 squared, which will give us the square root of 14. Finding the absolute value of the vector PQ dot the vector N will give us the absolute value of negative 12, which is 12. Now we can just go back to our distance formula that we derived earlier, and we can plug those numbers in, which will give us 12 over the square root of 14. Then when we rationalize that function, we wind up with 6 times the square root of 14 over 7. I hope this helped. Thank you.